All right, let's get started. Hello and welcome to this quick session about KEDA, about Gateway API, and hopefully you will have a chance to learn a thing or two about how KEDA and Gateway API can complement each other and work together. My name is Jan Wozniak. I work at a small startup called KEDA. We help to maintain KEDA and enhance its functionality with a couple of extra features. And in case you were wondering, no, I'm not related to Steve Wozniak. The only thing that connects me to Apple is this old cable that I stole from my wife. What you can expect today, we will take a look at Gateway API. We'll also take a brief look at internals of KEDA. Then I'll introduce you to a newish feature or add-on that complements KEDA functionality. It's called HTTP add-on. And during each block, after, there is going to be a short part of a demo. There's a couple of QR codes right now. You can take a look at the presentation that I'm sharing right now. You can take a look at the GitHub where the source code for the demo resides. And also for the demo part, I'll be using killer Coda, which is a killer Coda. It's a phenomenal thing. I really love it. The only unfortunate thing is that it works well when you do it at home. When a lot of people connect to the same scenario, sometimes there becomes a little bit of a delay. But you can either just observe what's going to be happening on the screen, or you can also try to run through the killer Coda yourself, either now or later. So the first thing, Gateway API. We're also going to do a little bit of an exercise. Let me do a quick poll. By the show of hands, how many of you know what a Gateway API is? All right, some amount. How many of you use Gateway API in production? Perfect, nobody. All right. So Gateway API, that's a new API for exposing your services outside of your cluster. Think Ingress, but a little bit on a steroids. We are going to take a little bit of a look into the internals, but don't worry, it will be helicopter overview from 50,000 feet, so not that much technical. First thing, there is a gateway controller, which takes care or understands two resources, gateways and routes. Now, technically, there's not just one type called route. There's HTTP route, gRPC route, blah, 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 and many other types of routes. But for our purposes, we are just going to call it a route. You configure gateway, which is going to be your external thing exposed to the external traffic. And then internally, the traffic is routed through other types of configuration, the routes. The gateway controller, his responsibility is to understand the gateway CRD and the route CRD and configure your Envoy, Nginx, whatever implementation of choice you have for your Gateway API. Oh yeah, and I also added a little bit of explanation here too, the same thing that I said. In comparison, let's take a look at the Ingress controller from, again, the same 50,000 feet overview from a helicopter. You have the external traffic, and you configure it through a resource called Ingress. Your Ingress controller very, very frequently serves as both the reverse proxy as well as the controller that is reconciling these ingresses and configuring how to route the traffic to the certain deployments and applications. So just for comparison again, this is your high-level overview of an Ingress controller. This is a Gateway API. It's nothing to be afraid of. You can quite easily migrate from Ingress controller to a Gateway API, and you will gain a good amount of extra functionality, I think. Now, looking at the source code, everybody loves source code on the slides. I can tell from the excitement on your faces right now. But to make it a little bit easier and make you less afraid of Gateway API, on the left there's HTTP route, on the right there's ingress. And let's take a look at some of the similarities. So you can configure it for host names. That's how you usually kind of start with the ingress. You can configure some prefixes. And also you can configure some backends, some backend references, where the traffic from the external is going to be routed in your cluster. And you tell it which implementation to use. Just like with the ingress and ingress controllers, you can have multiple ingress classes, same for the HTTP route. You have a Gateway API as a spec, and then you can have multiple different implementations and multiple different gateway classes in your cluster. Some notable differences. Ingress, for the same host name, for the same path, you can configure a backend. With HTTP route, you can actually configure more than one backend. You can have a certain strategies, how to route the traffic. In this case, it's using weight distribution. So that means it will load balance between the two services, 10% of the traffic to app 1 and 10 to app 1B. 90% to app 1B. There's also additional features. You can apply some filters. Now, not only you can apply the filters on the whole HTTP route, you can also apply filters on the specific backends. So if your application expects certain HTTP headers, you can enhance the request with HTTP headers or URL rewrite strategies. This would be a lot harder to do with ingress. I wouldn't actually know how, to be honest. Another pretty cool feature of Gateway API is a reference grant. Now, with ingress, you have to reference a service that's in the same namespace. You don't have the luxury to referencing a service in a different namespace. With Gateway API and routes, you can tell Kubernetes that you are going to be referencing a service in a different namespace, that you can cross the namespace boundaries. This is useful if you have a certain traffic control in place, and you need the traffic for all of your applications to first go through your traffic control. Technically, for the ingress, you can do a similar hack, which is with a service of type external name. And just like with the reference grant, you define your source. Where is your ingress? Where is your HTTP route? And where to route it. This is useful for these types of scenarios, but only supported by a small subset of ingress controllers. So, like for example, AWS ALB, that one doesn't support it, despite the fact that there is a community PR open for about a year, and currently nobody took a look to review it. So, yeah. Now, we talked a little bit about Gateway API. There's the promised part of the demo. This one will be super quick. If you go through the Clear Coda yourself, there is the entire setup, how to configure everything, including the Metal LB. For now, we'll skip the first part. I actually already executed it. But we can take a look at the resources that we discussed. Now, at least one. So there is a gateway. It was successfully configured. How can I tell? It's programmed. It's telling that it's true. And it has received an IP address. You can already hit the Gateway API endpoint. Now it returns 404 because we haven't configured any routes, but it's already running and it's already functional. And I told you this one is going to be quick. So I'm just going to hop back to the presentation. And KEDA. We'll do similar exercise as in the beginning. How many of you know KEDA? All right, much more hands got up. How many of you use KEDA in production? A couple of hands, nice, yeah. So just a quick recap, Kubernetes event-driven autoscaler. helps you to scale your applications based on external metrics or whatever other systems you have in place. A quick overview of the KEDA internals. It splits in two parts. One is the operators and pods running that are part of the control plane, and configuration, how you configure your certain applications, so scaled object, trigger authentication. Now, technically, there's more than that. There's also scaled object, which pairs with scaled job, which pairs with scaled object, cluster trigger authentication, which I think is running for a contest for longest running name of a CRD in Kubernetes. And there's also cloud event source. But for our purposes, we are going to skip them and just take a look at the core parts of KEDA. The easiest part, webhooks. I think everybody knows how webhooks work by now. You have a Kubernetes API. You try to apply your CRDs or custom resources, and the webhooks either initialize it for typical dynamic admission control, for validation or mutation. The operator, that's a little bit more complex. Let's start with a scaled object. So your scaled object targets a workload. That can be either a deployment, stateful set, also Argo rollouts are officially supported. Technically, anything that has a scaled sub-resource should be supported. And also jobs, if we talk about the scaled jobs as well. The operator sees a scaled object created, it will reconcile it, create an HPA. Another exercise, who knows HPA? All right, everybody. So I don't need to explain that HPA is a horizontal pod autoscaler, and it helps you to scale pods in numbers, and also pushes the metrics to metrics API. More about that later. The operator also is responsible for scaling the workload to 0, so the pods disappear, and to 1. The other scaling is done by the HPA, scaling workload from 1 and further, and then back. Where does the operator take the metrics from? Now, that's configured through the scaled object. Also, your systems frequently have some authentication in place. So that's why we would have a trigger authentication. And the operator from the scaled object trigger will know how to authenticate to your 65 supported external scalers. There's not all 65 here. A, they wouldn't fit in, and B, I just wanted to take the nice pictures that I liked. So that's the operator. And the last one is metrics API. That's an adapter that implements the metrics API in order to be plugged into the aggregation layer of Kube API. So you have your HPA. HPA is interested about certain metrics for your workloads. So it knows how to scale up or down. The Kube API delegates the request to metrics API. Metrics API actually asks the operator, because operator is the only one from KEDA that knows how to authenticate and query the 65 supported external scalers. So those were all the basic workflows of KEDA. Let's go back again to our demo part. Before I started, I just installed a metric server. Again, the killer KEDA environment is pretty bare. There's not much. Let's take a look. Yeah, it's already healthy. With the metric server, you can take a look at the basic metrics like CPU and memory. And the kubectl comes with a very convenient way to query these requests. But you actually also can explore the API yourself. First thing to start is to take a look at the API service API registration, which is where you configure the metric server to be plugged in to the Kubernetes API. And you can see that this is not served by the main Kubernetes API service, but this is from the metric server. Now, metric server, there are a lot of different types of metrics and metrics applications like Prometheus. Prometheus is fantastic. It's a phenomenal tool, and it also stores historical metrics. This particular metric server, it's only used for autoscaling. There's no history of the metrics, and it should be used together only with the HPA. But you can also take a look at some of the internals. And you can also take a look at directly the REST API endpoints. Now, for the metrics, we see that there are two resources registered. One is called nodes, and one is called pods. And you can also query directly the JSON responses. And you see that the metric server gives you CPU and memory metrics for you to consume. Now let's also install KEDA, and I just realized I forgot to click this one, so this will take a little bit of a time, but hopefully not too much. And also to become ready. And I'm running out of questions, so maybe by a show of hand, how many of you use Linux as your operating system? Nice. How many of you use Mac and Apple? Nice. We will distribute swords and weapons later, and you can fight it off. I was hoping by now it would be done, but yeah. Lacking to figure out some controversial topics to discuss now.
Maybe you can answer the question from the slide.
Sure, yeah. Is there any place I can see the question, or do I have to stand up?
I can read it for you.
Oh, perfect.
Okay. There is a question: how many pending connection can it handle? I mean, when I make 1K HTTP calls and pod isn't there yet, will all of them be served eventually?
Excellent question. And actually, I'm surprised who asked this, because a colleague of mine asked me the same thing in the morning. And I wouldn't have known if he didn't ask me, but we checked it. That's actually a topic we'll cover a little bit later, so I suspect maybe my colleague already asked me the question here that you see. This will be about the HTTP add-on and how it intercepts traffic. And I'll get to it a little bit later. By default, I think it's 100 connections. Don't quote me, I have a horrible memory. I looked it up in the morning and I already forgot. But anyways, the deployment of KEDA got ready, it's healthy. We can actually verify that. So these are the bits and pieces that we discussed. There's the metrics API service, KEDA operator, and the admission webhooks. There's 3 more pods, and they all relate to the HTTP add-on. Now, I'm going to go back and tell you a little bit about the HTTP add-on. It has a new CRD called HTTP scaled object. We are very creative with the names. So it's not only scaled object, but now you have also HTTP scaled object. And it comes with a new reverse proxy kind of for your traffic. Now, HTTP add-on is something that you would use to scale your application based on the HTTP traffic. So if you get 100 requests per second, maybe you're fine with 1 pod. If you get 5,000 requests per second, maybe you need to scale up. In order for KEDA to know how to scale up and how your HTTP traffic and how much of HTTP traffic do you have, there is this reverse proxy called interceptor. You configure your application ingress or gateway API routes to route the traffic to interceptor, and then interceptor, with help of the HTTP scaled object, knows how to route the traffic back to your application deployment. It's also good for one more functionality, and that is you want to scale down to 0. You want to have 0 pods. Like with CPU metrics and memory metrics, you can't really do that because it will never scale up again because it will remain 0 forever. With interceptor, it caches the request, And then rest of the HTTP add-on will try to spin up your application back to a running state. You'll experience a little bit of a cold start, and then it will forward the request. The operator is something that reconciles on the HTTP scaled object and creates a scaled object, which is a resource that KEDA understands. And there's also a scaler. Scaler is implemented as external push scaler for KEDA, a way how you can plug your own implementations for your own triggers directly to KEDA, and it understands the metrics from interceptor. It understands how many requests per second are being handled by the interceptor per certain application, and exposes those metrics to KEDA. So let's go back. Now we have covered the HTTP add-on, and we can take a look at a new thing here. So right now, if you discover the API service API registrations, not only you see the metric server, something that we installed some time ago, but you can also see the external metrics, which is how KEDA plugs in the external metrics from your Kafka, from your MySQL server, from all the 65 supported scalers, how it plugs those metrics to KubeAPI. Now, finally, we are getting to where these two can play together and have some overlap. I have a really trivial and boring application that I would like to show you really quickly. It's an HTTP server, and on this endpoint, it responds, very trivial response with its version and its IP address. So that's the code, and I'm going to deploy the application in two versions. One is called Blue, and a Blue service, and the other one is called Purple, and a Purple service. And also, I am going to expose it with an HTTP route. The traffic is going to be routed 50% to Blue service and 50% to Purple service. And we are going to observe the deployments. Now, this is the reason why I call them Blue and Purple, because of the colors. So here you can see the number of pods running. Each one is running with one. It's not auto-scaled yet. And here is a number because I apparently can't count the number of rows, so I also have a counter here. Let's just split the window, and we can hit the endpoints and see what they respond. And as I mentioned, the response is pretty trivial. Maybe without the HTTP headers, it's a little bit more readable. So each service responds with his version, so Blue and Purple, and IP address. There are a couple of handy scripts which put a couple of extra functionality on top of the curl. So we can call it in a batch of 10 requests and get some basic statistics. And we can also keep it running periodically. And at that point, every second, there's going to be a new batch of 10 requests. Now, quickly back here, auto-scaling. And as I mentioned before, this is your application. You have a route, you have your application, the traffic right now flows directly. What we're going to do next is put KEDA and especially the interceptor in the middle. So the route will route the traffic to interceptor, that one will route it to application, and also it will expose metrics to a scaler, and KEDA will take care of the scaling together with HPA. And yeah, that's the last slide from the theory, but we'll finish the demo. So I'm going to create an HTTP scaled object to tell the HTTP add-on and KEDA how to auto-scale. And instantly you can see the Blue application is going down. Oh, this is a HTTP scaled object for the Blue application. And we can already see some metrics. And there are 0 requests per second going to Blue, which checks out. No one's querying the endpoint. HTTP scaled object for the Purple Again, right now there's no pods running. We have just a couple of metrics. And also for the demo purposes, I'm going to make KEDA a little bit more aggressive with the scaling. But for production, you don't want to use that. Now the cool feature from Gateway API, the reference grant. So I can reference KEDA being deployed in a KEDA namespace and my application sitting in my application namespace. And I'm going to reconfigure the route finally. Now let's generate some load. And this is an interesting quirk. And it's starting to work. OK. It should, by now, yeah, it's now responding. Nice. You were able to see some red numbers and higher delays. That's because the application experiences some cold start. And it takes a little bit of time for the request to hit your endpoint and come back to the client. Interceptor, again, caches the request for you. And we can see that there are roughly 2 requests per second for each of the versions. Again, it's getting load balanced. And what is another pretty cool thing you can do, or maybe that will be too small. Maybe I'm just going to use the killer KEDA tabs. What we can do is edit the HTTP route directly. And here are the weights. So we are sending 50% of the traffic to blue and 50% of the traffic to purple. Let's make it 10% to blue and 90% to purple. When I come back, you can see the responses. We are getting responses mainly from the purple. Sometimes there's some blue, sometimes there's no blue. Long-running average will be 10% to 90%. The metrics from the interceptor for blue one are coming down. There's fewer and fewer requests hitting the blue endpoint. But there's more load coming to the purple one. And KEDA is starting to take some actions. And not only that I can't count, apparently I can't also figure out colors because this counter is flipped. There's just 2 blue applications and there's 4 that are purple. And it will continue to balance the entire traffic further. And I think this is a pretty powerful feature that, like, of course, you can do blue-purple or blue-green deployments and canary deployments with other technologies. But KEDA is widely adopted. Gateway API is kind of a standard that is getting adopted. And here you don't need any third-party application. And also here you declaratively tell Kubernetes, route this much traffic to my versions of the applications. And KEDA will take care of how many pods it actually needs. It will figure it out for you. You don't have to tell it, spin up 10 blue and 90 purple and make them pretty much idle, most of them. Here you just tell, portion of the traffic goes here, the other portion goes there. Please KEDA, figure out how many do I need. And that concludes the demo part. Thank you very much for your attention. I'm going to show the QR codes in case you are interested in trying the killer KEDA at home and learning more details about Gateway API and KEDA. Thank you very much.
So we have one question, or maybe a few more. So there is Wojciech Mareš asking, what is the performance latency impact of the interceptor on the HTTP traffic? Is it a good idea to use for real-time apps?
Excellent question. This one is not prepared this time. This is not from a colleague. Right now, we have started just some initial benchmarks for mock environments, and we see that there actually is a performance overhead. We saw the latency to grow by about 10 milliseconds from 20 to 30 milliseconds. And we also observed that requests per second went down from roughly 2,000 that we were able in our mock scenario to 1,600. And that was the same environment, same application, just putting the interceptor in front of it. A bigger scale benchmark is going to be performed, hopefully, this month by Lidl. They are evaluating it on a much, much bigger scale with a lot of applications. And I think if like Lidl, for their thousands of applications and thousands of requests per second are evaluating it, then hopefully it should be good enough for production environments. But we are going to learn more, and you are more than welcome to come and join our community calls. KEDA has public community calls every other Tuesday at 5 p.m. You can find the schedule on GitHub, KEDA/KEDA. And it's actively currently being discussed there.
We have other question. So how does HTTP scaled object compare to scaled object based on Prometheus metrics exported from ingress controller or gateway?
Another excellent question. So with the Prometheus metrics, that one is a pull type of a scaler. So you pull periodically every 30 or 45 seconds, I don't remember exactly, the metrics from Prometheus. So there's the initial delay. Then the HPA is getting, again, the metrics with some additional polling period. So there is additional delay. And at Lidl, they observed that sometimes it takes up to almost 2 minutes with the Prometheus workaround for the application to start scaling effectively. With the HTTP add-on, it can be configured to be almost instant. Like we saw during the demo, that it almost instantly started to scale up. And that's something you can't easily reproduce without significant overhead with Prometheus.
Mm-hmm. Thank you. We have other question. How interceptor know the pod is up and ready for request? Pod status, some health check, or just to try?
Yeah, so it looks at the Kube API, and it looks at the pods and endpoints for a certain service. And whenever a service has an endpoint that's by the service considered healthy, it knows that it can forward the traffic.
Mm-hmm. And one more question, and we will finish with that. Wojciech Maroš asked, what about WebSockets? Any support or plan for it?
There is an open PR at the moment. It's using the hijack mechanism from Core Go. It's currently under review. It may take a little bit of time because we, the maintainers, don't exactly know how the WebSockets hijacker works. And we just noticed in the documentation, in the official docs, that then you're responsible for taking care of the rest of the TCP session that you are responsible for closing. And the PR doesn't do it, so we need to figure out a proper way how to handle the WebSockets, because we don't want to have any memory leaks in the interceptor. So it may take a little bit of time, but some work is already being done.
Mm-hmm. Thank you so much. This was last question.
Thank you.
And we will start with the next session in 5 minutes. So thank you.
Right.